Hi everyone, I'm Cheryl. In this problem, we're going to be using cylindrical coordinates to help find the mass of the solid defined above when the density function is k times the square root of x squared plus y squared. Well, since we're going to be working in cylindrical coordinates, let's go ahead and change our solid so that it is defined in terms of cylindrical coordinates. So z is going to be between 0 and 9 minus r cosine theta minus 2r sine theta. And x squared plus y squared is less than or equal to 4 can be written as r squared is less than or equal to 4. All right, I'm going to do the same thing for my density function. So for my density function, instead of being in terms of x, y, and z, it'll be in terms of r, theta, and z. And so my function is k times the square root of r squared, which is k times r. Okay, so now that I have everything converted to cylindrical form, let's go ahead and take a look at the mass. I know that I can calculate the mass by using the triple integral over a solid of the density function, and again, I'm still working in x, y, and z, times dv. That's my basic formula. But again, I want to switch this so that I'm working with cylindrical coordinates. So it's still going to be a triple integral. My density function is going to be k times r. But dv, if I'm looking at it in cylindrical coordinates, is going to be r times dz, dr, d theta. Okay, so that's the basic setup, but I still need my limits of integration. So I'm integrating first of all with respect to z. So I know z is going to go from 0 to 9 minus r cosine theta minus 2r sine theta. Next, I'll be integrating with respect to r. Now, r squared is less than or equal to 4. That's going to be a circle of radius 2. So for a circle of radius 2, the r values are going to be going from 0 to 2. And to get the whole way around that circle, I need theta to go from 0 to 2 pi. All right, so I need to do a little simplifying here of the integrand, but my mass integration problem is set up. So let's just do that one more simplification step. The integral from 0 to 2 pi, 0 to 2, 0 to 9 minus r cosine theta minus 2r sine theta. And this will be k r squared dz, dr, d theta. Okay, so with a triple integral, we'll start with the inside integral first of all. And I also notice at this point that k is a constant through the whole problem, so I can pull it to the outside. So let's write that as k times the integral from 0 to 2 pi, the integral from 0 to 2. And now let's integrate r squared dz, which is just going to be r squared z, evaluated from 0 to 9 minus r cosine theta minus 2r sine theta, and this is dr d theta. Okay. So plugging in my upper and lower limits of integration into the z values, I'll have r squared times the quantity 9 minus r cosine theta minus 2r sine theta. When I plug 0 in for z, I just get 0. So I'm finished with this part, and I still have my dr d theta written. Okay, let's move up. So I have k times the integral from 0 to 2 pi, and I'm ready to integrate this with respect to r. Now I think what I'll do is I'll go ahead and distribute that r across to help me out a little bit with the integration. So let's go the integral from 0 to 2, and this will be 9 r squared minus r cubed cosine theta and a minus 2r cubed sine theta, dr d theta. Okay, so I'm ready to integrate. Right? I'm integrating with respect to r. Actually, it's all of this. Okay? So that means I can treat theta as a constant. So when I integrate, I'm going to have 9r cubed all over 3. So that's going to be a 3r cubed. This is going to be a minus r to the 4th all over 4 times the cosine of theta, because remember, theta is a constant, so is cosine theta. Then I'll have minus 2 r to the 4th all over 4, which is going to be minus r to the 4th all over 2 times the sine of theta. Again, theta is a constant, so is the sine of theta. And then I'll evaluate this from 0 to 2, and I still have my d theta. Okay, so k times the integral from 0 to 2 pi. Plugging in a 2, I'm going to have 2 cubed is 8, so that'll be 24. This will be 2 to the 4th is 16 over 4, so that'll be a minus 4 cosine theta. And again, that'll be 16 over 2, so that will be 8, so minus 8 sine theta. I have to subtract what happens when I plug a 0 in for the r's, but that will all be 0. So I have d theta. And now I'm ready to integrate with respect to theta. So I still have that k that's floating out there, and I'll have 24 theta. The integral of cosine is sine, so minus 4 sine theta. And the integral of sine theta d theta is going to be a negative cosine, so that'll be a plus 8 cosine theta. And all of that will be evaluated from 0 to 2 pi. So plugging in 2 pi, I'll have 24 times 2 pi. That's 48 pi. The sine of 2 pi, that's 0, so this term will be 0. The cosine of 2 pi is 1. 1 times 8 is 8, so that'll be an 8. And then I have to subtract what happens when I plug a 0 in, so that'll be minus k times the quantity. This will be a 0. The sine of 0 is again 0, so that'll be minus 0. And the cosine of 0 is 1, so I'll be adding an 8. So altogether, k times the quantity, 48 pi plus 8, and then I'll also have a minus 8. And so I end up with 48 k pi for my mass. I hope that was helpful. Thanks.